Welcome to PQSense Installation Guide. Today we'll guide you through the installation of your smart temperature monitoring system, step by step. With the right steps, follow along, and your equipment will soon be under 24/7 temperature surveillance, wirelessly and worry-free. Let's take a look at the core components. PQSense readers come in two models, a compact version and a larger unit with advanced capabilities. The larger model can send data to both the display and the central SCADA system at the same time, perfect for advanced monitoring environments. In this video, we'll demonstrate using the larger unit for clarity, mounting onto a DIN rail with a mounting clip accessory. You may contact PQSense when ordering to request this clip for DIN rail, if it fits your use case. Next, the antennas, designed to communicate with sensors inside the switchgear. Next, the display. This shows real-time temperature data, helping you identify hotspots at a glance. And here are the sensors. Each type is built for different positions: cable joints, contact points, or bus bars. The installation can be completed in a few simple steps. Start by mounting the reader. Snap it into position until it's securely fixed. To power up the reader, pull electricity from the cabinet's existing source, preferably through a breaker. It is a safer setup and makes maintenance easier. From there, run the output to the reader, connecting to P and N on the terminal block. Now the reader is powered and ready to be used. Next, let's connect the antennas. Extension lines should be connected one by one to the ports labeled ANT1 through ANT4. Each port corresponds to an antenna. Finally, we connect the RS485 lines D+ and D- to the corresponding terminal block. This connects to the display, transmitting the temperature data via Modbus RTU. Sensors should be attached directly to the key hotspots that require monitoring. PQSense offers 5 sensor types. Each serves at different locations with different mounting capabilities. The SR01 is made for metal surfaces like bus bars or bus bar contacts. It can be mounted by screwing down bolts or using heat-resistant cable ties, or both. The SR02 is designed specifically for plumb contacts on circuit breakers and can be mounted with heat-resistant cable ties. Place the sensor directly on the small metal gaps on the plumb contact and secure with heat-resistant cable ties. The SR03 is a closed silicone loop, resistant of high temperatures, mainly used for male contacts on circuit breakers. Slide the silicone loop directly over the male contact to install. The SR04 is a flat sensor for metal bolts. It cannot be mounted flat directly on metal and is usually used for cable tie bolts. Position the sensor after the cable connection joints with washers and fix down with a simple nut. The SR05 is also for metal surfaces like bus bars or bus bar contacts with a flatter profile. It can be secured by using 2 heat-resistant cable ties. There is also a strap-type fixture that can be used with SR05 and SR03. Simply take the sensors out of their original fixtures and strap directly on cables, bars, or desired location. For this example, sensor types SR02 and SR01 is used, installed on plumb contacts and bus bars. Moving on to the antennas. Antennas should be positioned based on the actual location of the sensors. To ensure stable signal transmission, place each antenna facing the sensors within the same compartment. In most setups, it's recommended to install 2 antennas on each side of the panel per compartment to ensure maximum stability and redundancy. Each antenna comes with a built-in strong magnet and can be directly attached to the metal wall inside the chamber. Once the locations are secured, use the extension cables to connect each antenna securely to the reader. Secure the antenna extension cables along the wall using cable ties paired with mounting clips to prevent loose cables. Next, install the display panel on the switchgear faceplate. We need to first cut out an opening for this display. Insert the display into the panel opening and secure it using the 4 corner screws. Start by powering the display. Our display requires an additional DC power supply. Connect the power source through another breaker and route the power supply's output to the display's power terminals. For wiring, connect the positive wire to V and the negative to G. This provides continuous power to the display unit. Next, connect the communication lines. Use RS485 cables. D+ goes to A and D- to B. Now we need to configure the reader. Connect a laptop to the reader using a USB-C cable and open the configuration tool. Enable each sensors that will be used for data collection. For each sensor, enter the ID based on its physical labels. Finally, press Set All to save the configuration. This provides the reader to acknowledge which sensor to communicate to. Once configuration is complete, our setup is complete. The reader should now retrieve data from sensors and push onto the display. If integration with a SCADA or cloud system is required, the reader's RS485 output can also be routed into any gateway that supports Modbus RTU, enabling further data transmission. PQSense temperature monitoring system is now live, fully integrated, fully passive, and always on. If a hotspot develops, you'll be the first to know, thanks to automated real-time alerts, visible on-site or remotely. Battery-free, wireless, and maintenance-free, PQSense brings modern, invisible protection to your most critical assets. Thank you for choosing PQSense, a small investment for a huge protection.